So in this video, we're looking at 7th grade. This is module 5, and we're going to be looking at all of topic C, which is going to be lesson 10, 11, 12, and 14. So percent increase, percent decrease. We're going to be talking about double discounts and then scale factor as a percent. So in this particular lesson, this is lesson 10 right here. Talks about percent increases. And it says that Maya decides to increase the prices at her taco truck. She increases the price of a beef taco from $1 to $1.50 and the price of a shrimp taco from $3 to $3.75. Which of these prices has a greater percent increase? Now, obviously, the shrimp tacos have a larger price increase at 75 cents, going up 75 cents, rather than the beef tacos only going up 50 cents. But is it the percent increase going to be the same? So we use the same formula that we've been using, same expression we've been using all this module. Part is equal to percent times the whole. And in this particular case, our part is going to be how much it decreased or how much it increased in this particular case. Next lesson is going to be decrease. So these prices went from $1.50 from $1, which means that she increased it by 50 cents. So that's going to be our part. Our part is going to be a 50-cent increase. We are looking for the percent, so we're going to go ahead and put a variable there. And the whole is going to be just like every other lesson that we've dealt with. The whole is going to be the original. So the original price in this case, it used to be $1. So you see we got a little bit of algebra right here to get P by itself. We're going to divide both sides by $1. And that's going to leave us with P being equal to 0.50, which means that she increased the price of the beef tacos by 50%. She increased them by 50%. So let's go ahead and take a look at the shrimp tacos. So part is equal to percent times the whole. In this case, she went from $3 to $3.75, which means she increased by 75 cents. Again, we are looking for the part, and our whole is the original price. So they started out at $3. So we divide again both sides by $3. And we get our percent is equal to 0.75 divided by 3. And that's going to give us 0.25 or an increase of 25%. So here you can see that even though the beef tacos only went up 50 cents, they have the bigger percent increase, meaning that if the cost of the tacos were $1, she increased it by 50%. 50% of $1 is 50 cents, so she went up $1.50. Whereas 25% of $3 is the 75 cents, and that's when she increased it to 75 cents. So it was a bigger percent increase by beef tacos. Next part says that she decides to raise the price of her salsa by 20%. So now they're giving us a percent in this problem. And the original price of the salsa was $1.75. Original price meaning that this is our whole. So part is equal to percent times the whole. We don't have the part. We do have the percent. And we're going to be multiplying that times the whole, which is the original price of $1.75. And we're going ahead and taking a look at what the new price is going to be. So we're going to change this percent into a decimal, which is going to be 0.20 times $1.75. And when you do 0.20 times $1.75, you get an increase. Remember, your part is your increase of 35 cents. So this is the increase, not the actual new price. So if she's increasing it from $1.75 and she's going up 35 cents, you can see that the new price is going to be $2.10 for salsa. So she went from $1.75 to the new price of $2.10. So percent increases don't just work on money, it also works on numbers. So if you see here, Maya adds a chicken taco to the menu. The first day she sells only 25 chicken tacos. She plans to display a photo of the chicken taco on the second day in hopes that the photo will increase the chicken taco sales by 40%. How many chicken tacos does she need to sell on the second day to meet her goal? So again, part is equal to percent times the whole. They had given us the first day. So the first day she sells 25 chicken tacos. That is our original number. We're trying to increase that. And we're trying to increase it by 40%. So we have 40% is our percent. Our whole is the 25 chicken tacos. Let's see what number we need to increase that by. So our part is equal to 0.40 times 25. So 0.40 times 25 is going to give us an increase. She needs to increase it by 10. So to meet her goal, she needs to sell what she sold originally and increase it by 10. To meet that 40% goal, she needs to sell 35 chicken tacos. This next lesson is lesson 11. This is going to be percent decreases. So same exact thing as percent increases, except now we're looking to see how much it went down by. So it says Lily and her family wanted to reduce the amount of electricity they could use in their home, or that they use in their home. They tried to conserve electricity and kept track of how well they did. In August, they used 1,156 kilowatt hours of electricity. And in September, they went down to 1,018 kilowatts of electricity. How much less electricity did they use? So that we're going to figure out this percent here. So again, they give us the original. So this is our original right here. So that is our whole. And then they give us the new one that they decreased it with as our part right here. Actually, that's not going to be our part. That's just how we're going to get our part. Our part is the decrease that we went down. So part is equal to percent times the whole. Part is either the increase or the decrease. This time they went down. They went from 1,156 down to 1,018. If we subtract those two numbers, you get that they had a decrease of 138. So that is going to be our part. We are looking for the percent that we decreased it by. And we have our original, our whole was 1,156. If we divide both sides by 1156, you get that our part, or our percent, is 0.11937. And we're going to go ahead and just round that number off. We can move this decimal 2 times to make it a percent. So that's going to be 11.9%. And if you want to just round into a whole percent, we can just go ahead and call it an even 12%. So they decreased their light bill by 12%. And then it says that Lily is proud that her family now uses less electricity, so she decides to share the results with her classmates. She tells them if we conserve electricity, we can do it. We can save at school as well. So do you think the school is only going to be saving 138? And the answer to that is more than likely not. School is a whole lot bigger than Lily's house. And they have a lot more people who can help conserve electricity than Lily have at her house. So the amount of kilowatt hours that they can save in a month would be far greater than Lily can at her house. Which brings us to problem number 3. Lily's family. Actually, we just solved that problem. That was what we did in number 1. So all of this is actually number 3. I just went ahead of myself. Here's what I want to talk about with Lily's school. So Lily's school used 70,520 kilowatts of electricity last month. The school makes a goal to reduce its electricity usage this month by the same percent as Lily's family. How much electricity can the school use this month and still meet its goal? So again, we're doing part is equal to the percent times the whole. We are trying to figure out how much can they decrease it by. How much electricity can they actually use if they keep the 12% that Lily's family went down and that their original is 70,520. So we're going to go ahead and change that to a decimal. Multiply these two numbers together. 0.12 times 70,520. And we get that they need to decrease their usage by 8,462.4. But it sounds to round to the nearest kilowatt hour. So we're going to go ahead and round that, like they say, to 8,462. That's what they need to reduce. They need to decrease their usage by. So to show how much electricity they can use to meet that goal, we're going to go ahead and take that 70,520 and decrease it by 12% of that, which is 8,462. So 70,520 minus 8,462 means that the school can use 62,058 kilowatt hours this next month and be able to meet their 12% decrease goal. And the next lesson is lesson 12, where we talk about more discounts. This is going to be multiple discounts on top of each other and different ways that we're going to be solving these discount problems. So we can easily work this problem out the same way we did it last topic, and again use our same equation. And this is the way that I prefer you to use it, but you got to understand that what parts you're finding here. So in this case, we are looking for the part because we have it originally priced at $4.25, which is our whole, and we have a % off coupon. So we are looking for the part. We're looking at to find out what is the discount, how much is the discounted by, and then they want us to figure out what is the discounted price. So that is two different things. The discount and the discounted price are two different things, and we got to make sure that we can read and understand that. So we've got 20% times the whole, which is $4.25. We turn our percent into a decimal like we always do. And we get that our discount is 85 cents. So that's the discount. That's how much they're taking off the $4.25. So to find the discounted price, we have to take the original price and then discount it. Take the 85 cents off. It's not on sale if you ain't saving no money. So $4.25 minus the 85-cent discount means the discounted price is $3.40. So there is other ways that we can solve this problem, or one other way. I still prefer that you would solve it that way. But if we're going to look at this other way, let's go ahead and take a look at it. So I'm going to go to and use a tape diagram to illustrate what I mean by this problem. So on tape diagrams, there are always some numbers that we can put. We can put a 0%, and a 100%. Now, if the original price is our whole, that means that it is valued at 100%. So our whole tape diagram would be equal to 425. And if they're taking 20% off, to be able to get to 20, to go from 0% to 100% and get to 20, we would need 5 boxes. So 1, 2, 3, 4, 5. So that means that each of these, this is 20%, 40, 60, and 80. If we were buying this thing at original price, that would mean that we are paying the entire tape diagram amount. We're paying all of $4.25. If we were doing this in 6th grade, where we would look at $4.25 and divide it by 5 boxes, that means that we would be at 20% is 85 cents. At 40 would be $1.70. At 60% would be $2.55. And then at 80%, it would be $3.40. And then again, if you would add another 85 cents, it would be $4.25. What they're telling us is that we are taking 20% off. So I need to take off a 20% block, which is, in this case, one block is equal to 20%. So how much are we paying now with the discounted price? We're paying 80% of the original price or $3.40 like we found. So another way that we could solve this problem is saying, okay, if I'm taking off 20%, let me do 100% minus 20%, and that lets me know that I'm paying 80% of the original price. So if we want to figure out what 80% of $4.25 is, we change our percent to a decimal. Of in math means multiplication. And when you multiply these out, 80% of $4.25 is equal to $3.40. Now that particular method, the second method, only works when you're talking about the discounted price. So when you see discounted price, you have to decide whether you need to use 20% or you have to use 80%. You're going to have problems that look like that, and that you have to decide which part you need to use. So the next problem talks about Mr. Jacobs. He purchases a globe that is originally priced at $15.95 and a book of maps that is originally priced at $12.35. He uses a 45% off coupon on the entire purchase, not just one item. And they want to know, what is the subtotal? What is the amount after the discount but before tax of the discounted prices of the globe and books? So first thing we want to do is figure out how much stuff he bought. So we're going to do $15.95 plus the $12.35. Add his two items together. So $15.95 plus $12.35 comes out to $28.30. That's going to be the price of what he's buying. That's going to be his purchase. So now we're going to take off that 45% off coupon. So part is equal to the percent times the whole. P is our discount. That's what we're looking for. How much money are we taking off? We're taking off 45%. He's buying $28.30 worth of stuff. Turn that percent into a decimal, so 0.45 times 28.30. That's going to give us, we're taking off $12.735. What in the world does that mean? We're talking about money here, so we need to round to $12.74 is what they're taking off. So they're taking this amount off of the $28.30. So let's go ahead and take it off. And that's going to give us a subtotal, a price that he's going to have to pay before tax of $15.56. Now, number 3, it says Pedro buys a drawstring bag that is originally priced at $7.60. After his coupons applied, the discounted price is $7.22. So this is the type of problem. It wants to find out what is the percent off. What percent off is Pedro's coupon? So how much money did they take off? So let's go ahead and use our part is equal to percent times the whole. It says originally priced, so that means that is our whole, which means that $7.22 is going to be our part. That's our discounted price. And we can leave it as a discounted price, but you're going to have to, we can do this problem 2 different ways. So if we leave it like this, which most people would, we're looking for the percent, and the whole is going to be $7.60. If we divide both sides by $7.60, you'll see that our percent comes out to 0.95 or 95%. Now, he didn't take 95% off, because if it went from $7.60 and you took 95% off, it would be way cheaper than $7.22. So in this case, because we kept this number at $7.22, we have to be able to understand that to find how much they took off, or the coupon they took off, we need to do 100% minus 95%, which means that he had a 5% off coupon. Now, if we did this problem the way we did it if we do this particular problem not as a discount, but more as a percent decrease. Or when we talked about discounts, we said that the discount was our part. So if we change this problem up just a little bit and understand what we're talking about here. So they want us to find out what his percent off coupon is. So we know that P is the discount. So let's see how much they actually took off. See what our discount really is first. So if we do 760 minus 722, we see that they took off 38 cents. Now we know that the discount is our part. So if I stick that in for my part, and I'm trying to figure out what the percent is, but I know that my original price was 760. Again, we divide both sides by 760, but this time my part is different. I get that my percent is equal to 0.38 divided by 760. And there is no other work I need to do because I get 0.05, which is equal to, move that decimal 2 times to the right, 5% right off the bat. So whether you subtract at the beginning or you subtract at the end, it all depends on what your understanding is of this particular problem. Number 4 says, after a 35% off coupon, the discounted price for a science kit is $17.42. What is the original price of the science kit? And this is the type of problem that you're going to have to understand when it says this discounted price. So it's $17.42. We got a 35% off coupon. So this is going to be a percent, but the discounted price, that is not a part. The discount is the part. It's not the whole because it's not the original price. So in this particular case, we can't use this number. We don't know what the original price is. We don't know what the discount is. So if I can't do anything to that number to change it, I need to look at this percent and change it. So if it's a 35% off coupon, that means that if I do 100% minus 35%, that would tell me that 35 looks horrible. But anyway, that would tell me that I paid 65%, which means that this number is 65% of my whole. So if it's 65% of my whole, that means that now it's a part because I changed that percent. It's part of my whole. So if I do part is equal to percent times whole, the 1742 is my part. 65% is my percent now because 1742 is 65%. So 65% times the whole. We turn that into a decimal. Divide both sides by 0.65. So 1742 divided by 0.65 lets me know that my whole, my original price, was $26.80. Now, if you're doing this on a test and you're like, man, I don't know if that's right or not, go ahead and throw it into a new problem. So I'm going to go ahead and show you how we can easily check this answer. So we were looking for the discount price. It told me I had a 35% off coupon in the original problem. So here's 35% off. 35% off of what whole? Oh, I just found it. $26.80. Let's check to see if this is right. Change that percent to 0.35. Multiply it times $26.80. So 0.35 times $26.80 gives me a discount of $9.38. And if I do $26.80 minus $9.38, I should come up with my discounted price. So $26.80 minus $9.38, I come out with $17.42, which is exactly what the problem gave me. So I know that my original price is correct. And that took me all of about 25 seconds to check. So now this last lesson, this is lesson 14. We did skip lesson 13. That was just a practice lesson of lesson 12. In this particular one, we're talking about scale drawings. Now, when we talk about scale drawings, way back in module 2, we talking like September. We did scale drawings using a scale factor that was just a number. And we knew that if the number was less than 1, it would be a reduction. So the picture, the original, would get smaller. If it was greater than 1, it would be an enlargement. And the same thing is true right here. If we do a picture, if I take this picture of this house and I use a scale factor of 100%, 100% is the same exact thing as saying 100 over 100, which is 1. So if I have a scale factor of 100%, I'm making a copy of this exact house. It would be the same exact size. But if I said I wanted my scale factor to be 50%, that would be 50 over 100, which is equal to 1/2, which is less than 1. So that means I would be making a reduction. This house would be smaller than it is right now on the new drawing. And if I said that I wanted my scale factor to be 150%, that would be 150 over 100, which is equal to 1.5. That number is greater than 1. So that means we will be having an enlargement. So the same method still applies. If you just look at the number, anything less than 100% is going to be a reduction. Anything greater than 100% is going to be an enlargement. Now let's see how we're going to use percents to figure out and draw a new house. So I'm going to flip the page. Oh, I'm not going to flip the page. I'm going to look at my book to see what the problem was. So for part A, it actually tells me that they want me to take 150% scale factor and draw this house all over again. So there's some numbers that I'm going to need to be able to do this. First off, I would like to know the base, and I'm going to put some letters right here. You got to remember what they are. So the base of my roof. So the base of my roof goes 1, 2, 3, 4. So the base of my roof is a 4. I need to know the height of my roof. So the height of my roof is here. That is 1, 2. I need to know the length and the width of my wall. So if we look at the length and the width of the wall, we got 1, 2, 3, 4, and 1, 2, 3, 4. So both of those are 4s. So I took care of the roof. I took care of the walls. Now I need to worry about the door. So the width of the door and the height of the door. The width of the door is 1 and the height of the door is 2. But then it's like a matter of where do I put the door when I'm drawing my new picture. Can't slap it in the middle because it's not in the middle of this one. So I'm going to go ahead and do a measurement, and I'm going to call it door from the right-hand side. And it is 1 unit away. The door is 1 unit away from the right-hand side of the house. And that's what I'm going to use. So I need to take these numbers and go ahead and put them in. And I'm going to show you how we still use the formula for this. So it's going to be part is equal to the percent times the whole. They want us to use 150%. And this is our original. This is the drawing that came first. It's our original. So that means it's our whole. We're going to take each one of these numbers and do a 4. We're going to turn that percent into a decimal. So 1.5 or 1.50 times 4. And that's going to give us the measurement of our new base of our roof. So 1.5 times 4. The new roof is going to have a base of 6. And that's really all we're going to be doing here. Now you can see all we're doing is taking the original number and multiplying it times the percent as a decimal. So I'm just going to go through here and do 4 times 1.50 and do that clean down the page for all of the numbers that we have. And then we go ahead and do the math and figure all of these numbers out. So 4 times 1.50 is 6. 2 times 1.50 is 3. We've already did the 4. We got 6s on those. 1 times 150 is obviously 1.5. 2 times 150 is going to be a 3. And then we got another 1.5 right down here. So now that we got all of our measurements and all of our pieces that we need, let's go ahead and take them, and we're going to create the new graph or the new drawing. So here we are on some graphing paper. You got a graph in your book, obviously. Went ahead and copy and pasted my numbers so that I don't have to look back at them. And we're just going to go ahead and start drawing. So first off, we'll go ahead and create the base of my roof. Make sure you got enough room for your height. Your height's got to be 3, so you got to be at least 3 tick marks from the top of your graph. And I'm going to go ahead and just start off with, you know what? I'll just go ahead and do the top of the roof. So if I go ahead and start the top of my roof right here. Let me get another little different pin to do this. So top of my roof right here. I need to go down a height of 3. So 1, 2, 3. That would put my bottom of my roof right here, 3 tick marks down. The base of my roof is going to be a 6, but the peak of my roof is this peak right here. That's the top. It has to be in the middle. So if my base is 6, that means I need to go 3 on each side. So 1, 2, 3. Here would be the left side. 1, 2, 3. Here would be the right side. That would still give me 6. So this line right here is going to be 6 units. Connect the rest of the dots. And there is the roof of my house. Now I need to do my walls, which were all 6s. So if I count down, 1, 2, 3, 4, 5, 6. There's the bottom of my wall. And if I go across, 1, 2, 3, 4, 5, 6. There's the corners of my wall. I'll go ahead and put those in. So there's my roof, then my walls. Now I need to figure out my door. Now we said that the door had to start 1.5 units away from the right-hand side. So if I go 1 and then another half, that would put me about right here. Let me try and get a smaller line than that. That would put me about right here. That's 1.5 units away. The width of my door was also 1.5. So if I go a half and then 1 whole, that lets me know where the other side of my door is going to be. And now I can worry about the height. The height of the door is 3 units. So 1, 2, 3. Here's the top of my door right up here. So now if I just connect those dots, I have my door and my enlargement at 150%. So if you go back and look at the other picture, it should be smaller than this one. This is an enlargement because we multiplied it times 150%. And now we can reduce it. So they wanted a reduction by 50%. So let me go ahead and paste those measurements back on here. Here's our numbers that we had for our enlargement. But now we're going to be reducing. So we're going to take all of these numbers. Instead of multiplying it times 150, we're going to multiply it times 50%. So get rid of that. And let's go ahead and do 50%. So half of 4 is 2. Half of 2 is 1. A 2, a 2. Right here is going to be a half. And a 1 and a half. So this is going to be a very small house. Again, we're reducing it. So let's go ahead and start with the top of our roof. And I'll go ahead and put the top of my roof just like we did before right here. It says the height of my roof is only going to be 1 unit. So if that's the peak that I just drew at the beginning, there's the bottom of my roof. The base of the roof is going to be 2. So again, if I'm in the middle, I got to go 1 to this side, 1 to this side, and that little thing is going to be my roof. And then if we look at the walls, the length and the width of the walls are 2. So we come down 2, go across 2, and finish up our wall. Now we got to talk about this teeny tiny door. So from the right hand side, the wall is only half a unit away. So my door starts right here. The door is only half a unit wide. So the door stops a half a unit away right here. And then the height of the door is only 1 unit. So it's going to come up to right here and come up to right here on that side. So if we connect this door, you see we got a really tiny house and we reduced it by 50%. This part right here comes from the practice in that lesson, lesson 14. And what they wanted us to do in the practice was to figure out what percent did we go from A to B. And you can use any number you want as long as it's the same number. So if you're using 2, you got to use 2.6. If you're using 4, you got to use 5.2. I'm going to go ahead and use the eraser side. So we're doing part is equal to percent times the whole. We're looking for the scale factor. Our part is going to be the second picture. So we're going to use 2.6 because we're looking for the part of the percent, the scale factor, and our whole, our original, is a 2. So to get our percent, we're going to divide both sides by 2. So 2.6 divided by 2 is going to give me I had to pause the video for a second. I thought my calculator was messing up. So our percent here, when we do 2.6 divided by 2, we get 1.3. Move that decimal 2 times, and you see we get a percent of 130%, which you can notice, it increases by 130% because figure B is an enlargement. You can also use that information to find missing numbers. So let's just say that we didn't know what this number was. So we use these 2 numbers and the problem that we just did to find our scale factor. So now all we have to do is use the 4 centimeters to find the missing number. So the way we would do that is part is equal to percent times the whole. We are going to be looking for our new scale drawing dimension. We know that the percent is 130%, and we see that our original right here is a 4. So if we do 1.30 times 4, you get the number 5.2, which was our missing piece. And you will see one like that on your test. We have to figure out what the scale factor is as a percent and then find the missing number. So make sure that you know how to do that particular problem. All right, this last one that we're doing wants us to enlarge this by a scale factor of 133 1/3%. So the first thing I'm going to do is I want to figure out a better percentage. I can even go ahead and change it to a decimal. So I want to take this 1/3 and do 1 divided by 3. And you'll see that that gives you 0.33333 repeating. We're going to go ahead and round it to 133.3%. And if I want to get rid of the percent, I'll move this 2 times. And that's going to give me a decimal of 1.333. And that's what I'm going to be using as my scale factor to go ahead and change these numbers. So let's get the first numbers. The first thing I'm going to do is I'm going to call this H. This is going to be my handle, because I'm thinking it's like a pitchfork. So here's my handle. It's 1, 2, 3, 4, 5, 6 units long. So I'm doing my percent, 1.333 times the height of my pitchfork, which was 6. Okay, then I'm going to be talking about how wide my forks are. So 1.333 times the width of this thing is 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I got the actual fork part. Those are 1, 2, 3 units long. And then the only other thing I need to know is what spaces goes in between these things. So I need to know the space of the forks. So that's going to be 1.333 times. Take a look at how far they are apart. 1, 2, 3. And then I can just go ahead and do the math. And these numbers, we're going to go ahead and just round to the nearest whole number. So when you do 1.333 times 6, you get 7.998, which would round to an 8. 1.333 times 9 is going to be 11.997, so 12. 1.333 times 3 is going to be 3.999, which is a 4. And then we got another 4. So let me go ahead and copy these numbers. I'm going to move to my graph paper. Let me paste this in so that we can look at it. And let's go ahead and start drawing these forks. So our handle is going to be 8 units long. So I'm going to go ahead and just start somewhere. Count down 8. 1, 2, 3, 4, 5, 6, 7, 8. Here's the bottom of my handle. And I'll go ahead and draw that handle. The fork's going across is 12, and the handle needs to be in the middle. So that means I got to go 6 to one side. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So that is going to be going across my fork. Each tooth of the fork, or each fork piece, is 4 units long. So 1, 2, 3, 4. And they got 4 spaces between them. So 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. And then I can go ahead and draw those pieces of the fork. And just like that, we have our finished enlargement. So that is everything that you need to know for your Topic C test. If you would like to have more practice, go ahead and work the practice problems out. If you want me to show you the answers, or you need to understand how to do a certain practice problem, whatever it needs to be, just message me on Google Classroom, and I can send you whatever information you need. It could be, I'll just send you the answer key if you need to, or if you need to make your little side video showing you how to solve the problem, just let me know. And as soon as we can get those tests taken care of, if you are at the alternative school, I'm going to go ahead and put those into Edulastic for you. Well, not Edulastic anymore. It's pair assessment. Still get to it on Clever. And if you missed that test this past Friday, you can take that test this week. Just let me know.